Imagine a prison cell with wallpaper. Not bars and stone, but something far more insidious. A comfortable English country house where the walls close in regardless of comfort, where the sentence stretches across decades, and where the warden is your own rebellious body. Within these walls, a mind burned so brightly it changed everything we understand about existence itself. This is not a story of triumph over adversity, though there's triumph here. It's something stranger. It's the tale of how suffering itself became the laboratory, how limitation forged insight, how a man too sick to attend scientific meetings rewrote the rules of life from his sickbed. Before we jump back in, tell us where you're tuning in from, and if these history tales fascinate you, make sure you're subscribed because tomorrow I've saved something extra special for you. The year is 1836. A young man steps off a ship onto English soil after 5 years circumnavigating the globe. His name is Charles Darwin, and he's 27 years old. His face is weathered, his notebooks bulging with observations, his mind crackling with ideas about finches and tortoises and the deep architecture of life. He's vigorous, alive, ready to transform natural history. Within months, this vitality will collapse into something that defies explanation for more than 150 years. Consider the mathematics of what follows. 23,000 days. That's how long Darwin will battle an illness that doctors cannot name, cannot treat, cannot understand. 63 years from that moment he steps ashore, until his death in 1882, and for 40 of those years, 14,600 days, his body wages war against itself. Yet from this siege emerges the most dangerous idea in science, an idea so powerful that 165 years after his death, we're still living inside its implications. The symptoms begin subtly. A stomach that rebels against food. Mornings that start with waves of nausea. Nothing alarming at first, perhaps the lingering effects of 5 years at sea. Eating ship's biscuits wormy with weevils, drinking water green with algae. But the symptoms don't fade. They intensify. By 1839, 3 years after returning, Darwin is recording attacks that leave him prostrate, unable to work, sometimes unable to stand. By 1841, he's documenting his suffering with the same meticulous attention he once gave to barnacles and beetles. Picture this daily reality. The day begins in darkness, somewhere between 6 and 7 in the morning. Darwin wakes already knowing what's coming. By 7 o'clock, the retching starts. Violent, uncontrollable. This isn't the brief nausea you or I might experience. This is his body trying to expel something that isn't there, convulsing with such force that his muscles ache afterward, that his throat burns, that he tastes blood. From 7 until 9, 2 full hours, this ritual repeats. His wife Emma moves through the house during these episodes, managing the household, shielding their children from the sounds behind the bedroom door. 9 o'clock arrives. The vomiting subsides. Darwin, exhausted, dresses himself slowly. By 10, on good days, he descends to his study. He has perhaps 2 hours, 3 if fortune smiles. Between 10 and noon, or sometimes 1 in the afternoon, he writes letters to correspondents across the world, observations about plant tendrils and orchid pollination, careful arguments about the transmutation of species thoughts so dangerous he keeps them secret even from friends. His handwriting, normally precise, sometimes deteriorates into shaking scrawls when the tremors in his hands worsen. Then comes the collapse. 1 o'clock, or noon, or sometimes even earlier. His body simply stops cooperating. Vision swims. Thoughts scatter. The pounding in his head makes concentration impossible. He must lie down. Not as choice, but as necessity. The afternoon stretches ahead in a fog of exhaustion. This schedule, this prison routine, repeats 6,000 times, 10,000 times, 15,000 times, year after year after year. Imagine your entire productive life compressed into 2 or 3 hours each morning, knowing that tomorrow will be the same, that next month will be the same, that next decade will be the same. Yet Darwin doesn't merely survive this existence, he transforms it into something revolutionary. The medical establishment of Victorian England finds itself completely baffled. Darwin becomes a curiosity among physicians, though not in the way he wants. They try everything. Doctor after doctor examines him, prescribes treatments that range from plausible to absurd. Cold water baths at 5 in the morning, bags of ice strapped to his spine, electrical chains draped across his body, sending current through his muscles in the vain hope of what? Shocking the illness away. Mercury compounds that poison him further, bismuth powders that coat his tongue grey, arsenic in tiny doses, opium to calm the spasms, morphine to quiet the pain. One physician becomes convinced the problem is psychological, a fashionable diagnosis that amounts to calling Darwin weak-minded. The cure? A water treatment called hydropathy. Darwin, desperate enough to try anything, subjects himself to it. Every morning at 5 o'clock, ice-cold water poured over his naked body, wet sheets wrapped around him for hours. The theory holds that this shock will somehow reset his system. It doesn't. The vomiting continues, the exhaustion deepens, but Darwin, ever the scientist, keeps detailed records of every treatment, every symptom, every variation in his condition. He's conducting an experiment with his own suffering as the subject. The illness baffles not just Victorian doctors but generations of physicians who study Darwin's case after his death. They have his letters, his diaries, his wife Emma's meticulous records of 20 doses of medicine administered daily. They have descriptions of symptoms spanning 4 decades, yet no diagnosis sticks. Tropical disease contracted during the Beagle voyage. The timing seems wrong. Symptoms appeared gradually, not suddenly. Chagas disease from an assassin bug bite in Argentina. Possible, but the symptom pattern doesn't quite match. A nervous condition brought on by the stress of developing a theory he knew would shatter religious certainty. This becomes a popular explanation, but it can't account for the physical violence of his illness. The rashes, the vomiting, the tremors. For 150 years, Darwin's illness remains medicine's most famous mystery. Dozens of papers are published, conferences held, theories proposed and discarded. The man who solved the mystery of life's diversity becomes himself an unsolved mystery. But here's what's remarkable. The illness doesn't stop the work, it shapes it. Darwin learns to work within impossible constraints, and these constraints forge new methods that accelerate his discoveries. Confined to his house, unable to attend scientific meetings or give lectures, he invents a different kind of science. He builds a global network through correspondence. 15,000 letters flow from his study to naturalists, pigeon breeders, gardeners, ship captains, anyone who might provide the observations he cannot gather himself. Can you picture this? A man in rural Kent, too sick to travel to London, yet receiving barnacle specimens from Antarctica, pigeon skeletons from India, seeds from Tasmania, flower samples from Brazil. The world comes to him, and because he must work in 20-minute intervals between rest periods, he learns a fierce focus that makes those minutes count. He cannot waste time, he cannot meander. Every moment of clarity must be maximized. The very rhythm of his illness begins to mirror the processes he's discovering. His health varies day to day, hour to hour, endless variation, the raw material of change. He struggles to maintain productivity, selection pressure, in its most personal form. Some routines work, others fail the survival of the fittest methods. His body becomes a living metaphor for the theory taking shape in his mind. In 1851, Darwin begins an obsessive 8-year study of barnacles. His family grows accustomed to the dining room table, covered with specimens, the smell of preserving fluids, the endless classifications. One of his children, visiting a friend's house, asks innocently, "Where does your father do his barnacles?" The child assumes every father spends years dissecting tiny crustaceans. Darwin examines 4,000 barnacle specimens during this period, identifying every species known to science. It seems like a distraction from his revolutionary theory. In truth, it's preparation. He's learning how variation works in exhaustive detail. He's seeing how tiny differences accumulate across populations. He's building the evidence base that will make his dangerous idea undeniable. But the illness extracts its price. Social life withers. Darwin and Emma develop a signal system when visitors arrive. She assesses his condition and either welcomes them or, more often, makes excuses. He cannot attend his own father's funeral. He cannot visit his sisters. He cannot accept invitations to scientific societies or university positions. He becomes a ghost in the scientific community, famous through correspondence, absent in person. The isolation has an unexpected benefit. Free from the social pressures of London's scientific circles, insulated from religious authorities by sheer physical distance, Darwin can think thoughts that would be dangerous to voice openly. In his study at Down House, protected by Emma's careful management of his time and health, he develops ideas that will horrify bishops and shatter certainties. Natural selection, the idea that life evolves without divine guidance, that humans are animals who've ascended from apes, that the apparent design in nature arises from blind processes of variation and selection. He knows these ideas could destroy reputations, could result in prosecution for blasphemy, could break his wife's heart, for Emma remains devoutly religious throughout her life. So he works in secret. For 20 years, 2 decades of accumulating evidence, refining arguments, building an edifice so thorough that when it finally goes public, it will be unassailable. The illness forces this patience. He cannot rush, cannot engage in hasty controversies, must build slowly, carefully, between bouts of vomiting. Then, in June 1858, disaster strikes. A letter arrives from Malaysia. The correspondent is Alfred Russel Wallace, a young naturalist working in the tropical archipelagos of Southeast Asia. Wallace has independently discovered the principle of natural selection. His essay, enclosed with the letter, outlines the theory Darwin has been developing in secret for 20 years. Darwin is devastated. He writes to his friend Charles Lyell, "Your words have come true with a vengeance that I should be forestalled." His body chooses this moment for complete rebellion. His daughter, Henrietta, falls ill with scarlet fever. The household erupts into crisis. Days later, his youngest son Charles becomes feverish. Darwin watches helplessly as the child deteriorates. On June 28, 1858, baby Charles dies. He's 18 months old. Darwin's own illness, already severe, transforms into something worse: grief, compounding physical suffering until he can barely function. Yet here, in the depths of catastrophe, something crystallizes. Friends arrange for Darwin and Wallace's papers to be presented jointly to the Linnean Society. The reception is muted. The president of the society will later remark that the year produced no revolutionary discoveries. But Darwin realizes he can no longer delay. If he doesn't publish his full theory, with all its evidence and implications, someone else will. His priority is established but not secured. He must write the book. What follows is a race between body and deadline. Darwin gives himself 13 months. He must take 20 years of research, hundreds of experiments, thousands of observations, and compress them into a single volume that will convince the scientific world. And he must do this while vomiting daily, while collapsing after 2 hours of work, while his hands shake too violently to write clearly. The manuscript that becomes On the Origin of Species emerges from this crucible. Darwin writes in his study overlooking the garden, but he might as well be in a cell. His world shrinks to the desk, the pen, the pages accumulating despite his body's betrayal. Emma brings meals he often cannot eat. She administers medicines that barely help. She reads his pages and despairs quietly at implications that undermine her faith, yet she never stops supporting the work. By November 1859, it's done. On the Origin of Species by Means of Natural Selection is published on November 24th. All 1,250 copies sell out on the first day. Darwin, unable to attend any celebrations or face any critics in person, collapses completely. The book goes out into the world while its author retreats deeper into illness. But the book fights battles its author cannot. Thomas Huxley, a fierce younger scientist, becomes Darwin's bulldog, defending the theory in debates and lectures. In June 1860, Huxley faces Bishop Samuel Wilberforce at Oxford in a confrontation that becomes legendary. Wilberforce sarcastically asks whether Huxley claims descent from apes through his grandfather or grandmother. Huxley responds that he'd rather be descended from an ape than from a man who uses eloquence to obscure truth. Darwin, hundreds of miles away at Down House, hears about these battles. Through letters, he's grateful, relieved. He cannot fight them himself. The theory spreads. Acceptance grows. Within a decade, most naturalists acknowledge evolution as fact, though debates about mechanisms continue. Darwin publishes more books from his sick room on orchid pollination, on earthworms, on human emotion. Each one advances the revolution begun by Origin. The invalid who cannot travel, cannot lecture, cannot engage publicly, nevertheless transforms biology, anthropology, psychology, philosophy. His prison becomes a fortress from which ideas emerge to conquer the world. And here's the deepest mystery. Would Darwin have achieved this without the illness? The question seems impossible to answer, yet consider what the sickness forced. It gave him time, decades of focused contemplation impossible in a busy public career. It gave him methods, the correspondence network, the experimental rigor, the meticulous documentation. It gave him safety isolation from critics during the theory's vulnerable development. It gave him metaphors, his own daily experience of variation, struggle, and adaptation. The illness that should have destroyed his productivity instead refined it into something unprecedented. Like a plant that grows stronger when trimmed, like a river that carves deeper channels when confined, Darwin's genius intensified under constraint. His suffering became the very laboratory in which his dangerous idea matured. We stand now, more than 160 years after Origin's publication, living inside the implications of those hours Darwin snatched between vomiting spells. Every biological discovery since then branches from his central insight. Every medical advance, every understanding of genetics, every conservation effort, every exploration of life's diversity, they all trace back to the sick room at Down House. And the medical mystery? It took DNA analysis of Darwin's descendants, conducted in the early 21st century, to solve what CONMA, Victorian doctors could not, a gene mutation MTHFR causing cyclic vomiting syndrome, a simple biochemical error in processing folate and B vitamins, creating the cascade of symptoms that defined Darwin's life. The answer was written in his very DNA, waiting 150 years for science to catch up. The invalid, who rewrote life's story, was himself a story that needed rewriting by the science he founded. There's a symmetry there, a poetry. The man who taught us that all living things share ancestry, that we're connected through deep time to every organism on Earth, was suffering from a condition coded into the very molecules that prove his theory. His genes, carrying forward through his children and grandchildren, eventually revealed their own secret, the explanation for his 40 years of suffering. But before we can understand that ending, we must go back to the beginning, before the sickness, before the sick room, before the decades of suffering. We must go to sea with a young man who has no idea what awaits him, aboard a ship called Beagle, bound for adventures that will change everything. The year is 1831. Charles Darwin is 22 years old, and he's convinced his life is over before it's truly begun. Not because of illness, his body still obeys him completely, vigorously, unremarkably. No, his life is over because he's a failure. He's abandoned medical training in Edinburgh after watching surgery performed on a screaming child without anaesthesia. He's drifted through Cambridge studying theology, a gentleman's degree for young men with no particular calling. His father, a successful physician, looks at him with disappointment barely concealed. "You care for nothing but shooting, dogs, and rat-catching," the elder Darwin declares, "and you will be a disgrace to yourself and all your family." Then, in August, a letter arrives. It's from Professor John Henslow, Darwin's botany instructor, the one person who seemed to see something in this aimless young man. The letter contains an invitation. HMS Beagle, a ship being prepared for a surveying voyage around the world, needs a gentleman companion for the captain, someone educated, someone interested in natural history, someone willing to spend years at sea for no pay beyond the opportunity itself. Would Charles be interested? Interested. The word barely captures what Darwin feels. This is rescue, redemption, a chance to be something other than a disappointment. His father initially forbids it a waste of time, a dangerous distraction, but his uncle Josiah Wedgwood intervenes, arguing that the voyage might settle Charles and might give him purpose. Reluctantly, his father consents. On December 27th, 1831, HMS Beagle slips away from Plymouth Harbour. The ship is tiny, 90 feet long, barely larger than a modern yacht, and it's crammed with 74 men, scientific equipment, 22 chronometers for establishing longitude, and provisions for years at sea. Darwin has a corner of the poop cabin, so small he must remove a drawer to fit his legs when sleeping. The ceiling is 5 feet high. He's 6 feet tall. This will be home for the next 5 years. Within hours, he's violently seasick. The ship pitches and rolls through the Bay of Biscay, and Darwin spends his first week sprawled in his cramped cabin, vomiting into a bucket, wondering what madness possessed him to agree to this torture. The seasickness will plague him for the entire voyage, thousands of miles, hundreds of days at sea, and he never acclimates. While sailors scramble up rigging in storms, Darwin clutches the rail and empties his stomach over the side. Yet something remarkable happens. Whenever Beagle reaches land, an island, a coast, a harbour, Darwin transforms. The nauseous invalid becomes an energetic explorer. He leaps ashore with collecting nets and specimen jars, geological hammer and notebooks, ready to walk 20 miles through jungle, or climb mountains that make his lungs burn. The pattern establishes itself early. Suffer at sea, thrive on land. His body seems to rebel against the ship but embrace everything else. The voyage's first major stop is the Cape Verde Islands, off the coast of Africa. Here, in January 1832, Darwin makes a discovery that plants the first seeds of revolution. He's examining a band of white rock running through volcanic cliffs about 45 feet above sea level. The white band contains shells, oyster shells, clam shells, the compressed remains of a seabed now suspended in mid-air. Darwin stares at this geological impossibility made fact. The land has risen. The seafloor has been lifted dozens of feet by some vast force operating over immense time. Or, and this thought strikes him with almost physical force, the sea level has changed. Either way, the earth is not static. It's dynamic, changeable. And if landscapes can transform so dramatically, what else might change? He begins collecting everything. Beetles, his childhood passion by the hundreds, birds, plants, fossils, rocks. He shoots specimens and skins them, He preserves fish in spirits. He fills jar after jar, crate after crate. The Beagle's hold gradually fills with Darwin's collections, shipped back to England at every opportunity. His letters home bubble with excitement. He's found his calling. This aimless young man has become a naturalist. But the voyage exacts its price even before illness strikes. In September 1832, Beagle reaches Tierra del Fuego at South America's southern tip. The weather is horrific, constant wind, freezing rain, waves that threaten to shatter the small ship against rocks. Darwin observes the indigenous Fuegians, nearly naked in weather that makes the crew shiver in their woolens. The contrast troubles him. These are humans, clearly, but living in conditions that seem barely survivable. The Victorian assumption of racial hierarchy, of civilization's linear progress, begins to crack in his mind. Humans can adapt to almost anything. We're more variable, more resilient, more diverse than English drawing rooms would suggest. In February 1833, he contracts a fever in the pampas of Argentina. For several weeks, he's bedridden in a stranger's house, suffering from something the locals call the fever, possibly influenza, possibly something more exotic. He recovers, but the episode marks the first serious breach in his vigorous health. The body that never failed him before has shown vulnerability. Then comes March 1835, and an encounter that may seal his fate. Darwin is collecting in the Mendoza region of Argentina. One night, as he sleeps, he's bitten by an insect called the benchuca bug, what we now know as the kissing bug or assassin bug. He records the incident in his diary with typical scientific detachment. At night, I experienced an attack from the benchuca, a species of reduvius, the great black bug of the pampas. It is quite disgusting to feel soft wingless insects, about an inch long, crawling over one's body. Before sucking they are quite thin, but afterwards become round and bloated with blood. He cannot know that this bug may carry Trypanosoma cruzi, the parasite causing Chagas disease. The parasite takes years, sometimes decades, to manifest its full effects. It can cause digestive problems, heart issues, chronic fatigue. Researchers studying Darwin's later symptoms will point to this bite as the possible origin of his 40-year illness. The moment that changes everything, recorded with scientific precision, its significance invisible at the time. But we're getting ahead of ourselves. In 1835, Darwin is still vigorous, still capable of extraordinary physical feats. In September of that year, Beagle reaches the Galapagos Islands, 600 miles off the coast of Ecuador. These volcanic rocks, scattered across the equator, will become the most famous islands in biological science. But Darwin doesn't immediately recognize their significance. He spends 5 weeks in the archipelago, collecting birds and plants and the famous giant tortoises, some weighing 300 pounds, ancient creatures that seem prehistoric. He notices that each island has its own species of mockingbird, slightly different, variations on a theme. The finches, too, show bewildering variety, some with heavy beaks for cracking seeds, others with thin beaks for catching insects, still others with beaks adapted for extracting nectar from flowers. Darwin collects specimens but doesn't initially label which island each came from. Only later, when ornithologists in London examine his collection and explain that each island has distinct species, does the pattern's significance strike him. These islands are young, volcanic, born from the seafloor, no more than a few million years old, yet they're populated with unique species. Where did these species come from? Are they separate creations, God making mockingbirds and finches uniquely for each island? Or, and this thought is dangerous, do species change, adapt, transform to fit their environment? The seeds planted in Cape Verde begin to germinate. If landscapes change, if species vary from island to island, perhaps life itself is not fixed. Perhaps the biblical story of creation, of all species made perfect and unchanging, is wrong. But the Galapagos aren't finished teaching him. In November 1835, Darwin climbs into the highlands of Albemarle Island, the largest in the archipelago. The altitude affects him immediately. His heart races, his breathing becomes laboured. At around 2,000 feet, he develops splitting headaches and nausea. This is altitude sickness, though he doesn't know the term. He pushes through, determined to reach the summit and examine the volcanic craters. The experience leaves him exhausted for days afterward. The month later, Beagle sails to New Zealand, then Australia. In January 1836, Darwin explores the Australian bush. The animals here astonish him: kangaroos and platypuses, creatures so bizarre they seem like nature's jokes, yet they fit their environment perfectly. The continent's isolation has produced a completely unique fauna, another data point in the accumulating case for species mutability. By now, Darwin has spent 4 years at sea, 4 years of seasickness between ports, 4 years of collecting specimens and recording observations, 4 years of geological hammer blows and specimen jars and notebooks filling with questions that challenge everything he's been taught. The voyage is scheduled to end soon. Beagle will complete its circumnavigation and return to England. Darwin is eager to go home, eager to examine his collections properly, eager to start making sense of what he's witnessed. But there's one more ordeal. In March 1836, Beagle reaches the Andes on the Chilean coast. Captain Fitzroy plans to survey the coastline, while Darwin explores the mountains. This is the opportunity Darwin has been waiting for, to examine the Andes geology, to understand how these immense peaks formed. He organizes a crossing of the Cordillera, the highest section of the range, with guides and pack animals. The climb nearly kills him. At 14,000 feet, the altitude sickness that troubled him in the Galapagos returns with crushing force. His head pounds so violently he can barely think. His heart races even when resting. Breathing becomes work, each inhalation an effort. He vomits repeatedly. His guides, accustomed to the altitude, watch with concern as this determined Englishman pushes himself to the edge of collapse. But the geology rewards his suffering. High in the Andes, at 13,000 feet, Darwin finds seashells. Not just a few shells embedded in cliff faces, entire seabeds lifted miles into the sky. The mountains themselves are ancient ocean floors thrust upward by forces so powerful they dwarf human comprehension. The earth is not just changeable, it's violent, dramatic, capable of transforming seabed into mountaintop over vast stretches of time. The implications cascade through his mind even as his body rebels against the thin air. If mountains can rise miles high, if seabeds can become sky-scraping peaks, all without divine intervention, through purely natural forces operating over immense time periods, then what can't change? What must remain fixed? Perhaps nothing. Perhaps everything is subject to transformation. He descends from the Andes, weakened. The exertion at altitude has drained him more than any previous physical challenge. For weeks afterward he feels the effects: persistent exhaustion, difficulty concentrating, a body that seems to have used up some crucial reserve. He doesn't realize it yet, but something has shifted. The vigorous young man who bounded ashore at Cape Verde 5 years ago is beginning to fail. The Beagle continues its survey work along the South American coast through mid-1836. In May, Darwin contracts another fever. The details are vague in his records, probably malaria or typhoid, common enough in tropical ports. He recovers, but slowly. The recoveries are taking longer now. The reserves aren't what they were. On October 2nd, 1836, HMS Beagle drops anchor at Falmouth, England. The 5-year voyage is complete. Darwin steps onto English soil a different person than the one who departed. His collections, thousands of specimens packed in crates, will make his reputation as a naturalist. His notebooks contain observations that will eventually revolutionize biology. But his body carries invisible damage, the fevers, the altitude sickness, the possible parasite from the benchuca bug, the 5 years of seasickness and physical stress. Something has been depleted. Something has been damaged. The symptoms will appear gradually over the coming months, but their seeds were planted during the voyage that planted all his other seeds. Look at the photographs that survive from different periods of Darwin's life. There's a sketch from the Beagle voyage showing a vigorous young man, lean and energetic. Then photographs from his 30s and 40s, the face has thickened, the eyes show fatigue, the posture suggests someone bearing invisible weight. The transformation isn't just aging, it's something else. The vitality has been drained away by something the voyage introduced. But here's the extraordinary thing. The same voyage that may have broken his body gave him the insights that would justify everything that followed. Those 5 years of observation provided the raw material for 40 years of revolutionary thinking. The species variation in the Galapagos, the geological transformations in the Andes, the diversity of life forms across continents, the extinction of huge mammals in South America, their fossils testament to species impermanence. Every piece of evidence needed to topple the old certainties about creation and species fixity. He gathered it all during those 5 years while his body accumulated damage. It's as if the voyage was a transaction. Darwin traded his health for insight. He paid with decades of suffering for the privilege of seeing what no one had seen before, not the facts themselves, which were available to anyone with eyes, but the pattern connecting them. The dangerous idea forming in his notebooks as Beagle sailed home would reshape human understanding of our place in nature. The price was merely 40 years of his life spent in a prison of illness. As the Beagle voyage ends and Darwin returns to England, he's standing at a crossroads he doesn't recognize. One path leads to the conventional success of a Victorian naturalist, describing new species, attending scientific societies, perhaps earning a professorship. The other path leads through decades of suffering into territory that will make him the most controversial scientist of his century. The voyage chose the path for him. The benchuca bug, if it did carry Chagas disease, made the choice. The altitude sickness in the Andes, the fevers in tropical ports, the 5 years of constant seasickness, they all made the choice. Within months, the symptoms will begin. Within years, they'll become his constant companion. But first, there's a brief window, a moment between the voyage's end and the illness's onset. A few months when Darwin is home, examining his collections, beginning to write, still feeling mostly himself. He doesn't know these are borrowed months, doesn't know the prison is being constructed around him even as he plans his future. The seeds have been planted, both kinds of seeds. The intellectual seeds that will grow into evolution, and the physical seeds, parasites perhaps, or damage from altitude and fever that will grow into chronic illness. They'll grow together, intertwined, inseparable. The suffering and the insight emerging from the same source, the same journey, the same 5 years that changed everything. The house sits in a valley in Kent, 16 miles from London but worlds away from the city's chaos. Down House. The name is almost prophetic. Down as in direction, down as in melancholy, down as in the state Darwin will spend decades inhabiting, but also down as in the North Downs, the chalk hills that surround this property. In September 1842, Charles and Emma Darwin move here with their 3 young children. They're fleeing London, where Charles has spent 6 increasingly miserable years trying to function as a public scientist while his health deteriorates. They need space, privacy, a place where illness can be managed without witnesses. Down House is not grand. It's a former parsonage, square and plain, built of weathered brick with windows that rattle in winter winds. But it has 18 acres of grounds, room for children to play, room for gardens and experiments, room for Darwin to be sick without the city watching. The house cost £2,200, nearly all of Emma's inheritance. They're betting everything on the hope that rural quiet will restore what London chaos destroyed. Picture the first morning after they move in. Darwin wakes at dawn, as he will for the next 40 years. The bedroom is modest. Emma has chosen furniture for comfort rather than fashion. Already the routine is establishing itself. By 7 o'clock, the nausea begins. Darwin barely makes it to the basin before the retching starts. Emma, in the adjacent dressing room, hears but doesn't enter. She learned early in their marriage that her presence during these episodes doesn't help. Better to let him suffer privately than appear afterward with weak tea and sympathy. By 9 o'clock he emerges, pale, exhausted, but determined. He descends the stairs to his study, a room he'll choose carefully, positioning it to overlook the gardens so he can watch his experiments through the window. The study becomes his world. 15 feet by 12 feet. Bookshelves covering 2 walls. A fireplace that's never quite adequate in winter. A high desk where he can stand to write when sitting becomes unbearable. A low armchair where he can recline when standing becomes impossible. This room, this modest rectangle of space, will be the laboratory where natural selection is refined from rough insight into comprehensive theory. Everything that follows every page of Origin of Species, every letter in his 15,000-piece correspondence, every experiment on orchids and earthworms and climbing plants, all of it emerges from this room. But the room doesn't exist in isolation. It's part of a carefully engineered ecosystem that Emma designs to keep Charles functional. Consider the complexity of what she manages. There are the children: William, Annie, Mary, Henrietta, George, Elizabeth, Francis, Leonard, Horace and Charles. 10 children born between 1839 and 1856. 3 will die young, a not uncommon tragedy in Victorian England, but devastating nonetheless. Emma must raise these children, educate them, protect them from their father's illness while ensuring they know him. She must also manage Darwin's medical regime. In the 1840s, before any diagnosis exists, they try everything. 20 doses of medicine per day become standard. Bismuth for the stomach, opium for pain, morphine for sleep, various tonics and elixirs whose primary ingredient is often alcohol. Emma keeps meticulous records. Time of day, dosage, symptoms observed afterward. She's conducting experiments on her husband's illness with the same rigor he applies to barnacles. The household staff must be trained to accommodate Darwin's needs. Meals prepared that he can sometimes eat plain foods, nothing spicy, timing adjusted to his unpredictable appetite. Quiet maintained during his working hours. The children ushered away when he needs rest. Visitors screened ruthlessly. Emma becomes the gatekeeper, the manager, the engineer of an environment where genius can function despite the body's rebellion. And there's a deeper complexity to what Emma endures. She's deeply religious, Church of England, conventional in her faith. She believes in God, in divine creation, in the immortality of the soul. And she's married to a man whose work is systematically destroying these certainties. She reads his drafts. She knows where his theory leads to humans as animals, to life arising without divine intervention, to a universe operating by blind mechanical laws. It terrifies her, not intellectually but spiritually. If Charles is right, what happens to her faith? What happens to the possibility of meeting again in an afterlife? Yet she never stops supporting his work, never suggests he abandon the research that threatens her worldview. She nurses the body that houses the mind, destroying her certainties. There's a kind of heroism in this that's almost unbearable to contemplate. Every morning when she brings him tea after the vomiting, every afternoon when she manages visitors to protect his work time, every evening when she reads his dangerous prose, She's enabling the revolution that undermines everything she believes, and she does it out of love. The grounds of Down House become Darwin's outdoor laboratory. He designs walking paths specifically for thinking. The famous sand walk, a narrow path circling through a wooded area behind the house, becomes his daily ritual. 1/4 mile long, sheltered from wind, carpeted with leaves. Darwin places a pile of flint pebbles at the start of the path. Each time he completes a circuit, he kicks aside one pebble. 5 pebbles means 5 laps. The mechanical act of counting frees his mind for contemplation. He walks this path thousands of times, 10,000 times, 15,000 times. Spring mornings when bluebells carpet the woods, summer afternoons when heat makes the air shimmer, autumn evenings when leaves crunch underfoot, winter days when his breath steams and his hands ache with cold. The path becomes so familiar that his body walks it automatically, while his mind wrestles with species and selection. Imagine what happens on these walks. A problem that seemed insoluble in the study becomes clear in motion. The question of how complex organs like eyes could evolve through gradual steps. He works through this on the sandwalk, building hypothetical sequences from light-sensitive cells to sophisticated vision. The difficulty of explaining altruism in nature, he paces this out, developing the concept of group selection. The mystery of how varieties become species, he counts pebbles while the answer assembles itself. The gardens become experimental stations. Darwin plants flowers and observes which ones attract bees. He covers plants to prevent cross-pollination and tracks the results. He measures growth rates, records flowering times, notes which varieties thrive and which fail. The entire property transforms into a living laboratory where theories can be tested on scales from single orchids to whole meadows. But this idyllic image of the gentleman scientist experimenting in his gardens conceals the daily reality of suffering. Let's be precise about what Darwin endures. His own records, combined with Emma's documentation, paint a picture of remarkable consistency. The morning vomiting almost every day for 40 years. We can calculate this. 40 years is approximately 14,600 days. Even accounting for variation, Darwin experiences at least 12,000 episodes of violent nausea. 12,000 mornings beginning with his body trying to expel something that isn't there. The duration is consistent too. 7 to 9 in the morning, nearly always. 2 hours of suffering as predictable as sunrise, then the exhaustion that follows, then the narrow window of productivity, then the inevitable collapse. Other symptoms come and go. Boils erupt on his face and scalp, painful enough that he cannot concentrate. His vision swims. The page blurs. Words lose focus. His hands develop tremors so severe he cannot write legibly, must dictate to Emma or his children. Headaches strike with crushing force. His heart pounds irregularly. Rashes spread across his skin. The variety is almost as exhausting as the symptoms themselves. He never knows which affliction tomorrow will bring. Victorian medicine has no explanation and worse treatments. In 1849, Darwin hears about a water cure establishment run by Dr. James Gully at Malvern. Gully preaches hydropathy, the use of cold water to shock the body into healing. Darwin, desperate enough to try anything, subjects himself to the regimen. The treatment is brutal. 5 o'clock every morning, a servant pours buckets of ice-cold water over Darwin's naked body. The shock is meant to stimulate the nervous system. Then he's wrapped in wet sheets for hours. The theory holds that the body's effort to warm itself will somehow reset his system. Afterward, more cold water. Compresses applied to his stomach. Drinking prescribed amounts of water at specific times. No coffee, no tea, no spices, no alcohol. Walking prescribed distances at prescribed times. Darwin follows this regimen for months. Does it help? The records are ambiguous. He reports feeling slightly better some days, but the vomiting doesn't stop. The collapses continue. What the treatment does provide is structure, a routine to follow. The illusion of agency in fighting something that seems otherwise uncontrollable. Back at Down House, the routine re-establishes itself. The morning vomiting, the brief work window, the sandwalk contemplation, the afternoon collapse, day after day after day. But within this prison of routine, the work advances. Darwin begins his systematic study of barnacles in 1846. This will occupy 8 years of his life. 8 years of dissecting tiny crustaceans, cataloguing every species known to science, examining 4,000 specimens under the microscope. To his family it seems like obsession or madness. Why spend 8 years on barnacles when you have revolutionary theories about life's diversity to publish? His son Francis will later write about childhood memories of the dining room table, covered with barnacle specimens in jars, the smell of preserving alcohol, the endless classifications. One of Darwin's children, visiting a friend, innocently asks, "Where does your father do his barnacles?" But Darwin isn't wasting time. He's building credibility. He knows his theory of natural selection will be controversial, potentially career-destroying. He needs to establish himself as a serious, meticulous scientist first. The barnacle work does this. It demonstrates his capacity for exhaustive research. It shows his attention to detail. It proves he's not a wild theorist but a patient observer. More importantly, the barnacle study teaches him about variation at microscopic levels. He sees how tiny differences accumulate within species. He observes hermaphroditism and strange reproductive strategies. He witnesses how organisms adapt to extreme environments, some barnacles attached to whales, others to volcanic rocks in crashing surf. Every observation feeds back into the larger theory developing in his notebooks. In 1851, tragedy strikes. Annie, his beloved daughter, falls ill. She's 10 years old, bright and affectionate. The illness begins as fever, then vomiting, then weakness that doesn't improve. Darwin and Emma take her to Malvern, hoping Dr. Gully's water cure can help. For days, Annie seems to rally. Then she declines again. On April 23, 1851, she dies. Darwin is devastated in ways that transcend description. Annie was his favourite. He admitted this to himself, if not to others. Her death breaks something in him. The faith he'd been losing gradually through his scientific work evaporates completely. What kind of God creates a world where innocent children suffer and die? The answer that forms is no God at all, just the blind mechanisms of nature, as disease as part of the endless struggle for existence. Emma's faith, tested by Charles's theory, is now tested by grief. She doesn't lose her belief. Instead, it deepens. She must believe in heaven, in reunion, in meaning behind suffering. The gap between husband and wife widens. They love each other deeply, support each other constantly, yet inhabit different spiritual universes. Annie's death changes Darwin's approach to his dangerous theory. He becomes more cautious, more thorough. He cannot afford to be wrong. The stakes are too high. If he publishes a half-formed theory and is dismissed as a crackpot, the truth about life's diversity might be delayed for generations. Better to accumulate more evidence, build an unassailable case, work from the fortress of Down House until the theory is perfect. So, he continues. Years pass. The 1850s advance. His children grow. His illness persists. The work continues in those narrow windows between vomiting and collapse. Letters arrive daily from around the world. Naturalists sending observations. Pigeon breeders describing varieties. Gardeners reporting on hybridization experiments. Darwin has built a global research network that compensates for his physical imprisonment. The world comes to Down House through the mail. He conducts experiments endlessly, seeds planted in different soils, flowers cross-pollinated in controlled conditions, plants grown in darkness to observe tendril movements, earthworms studied in glass cases to understand how they process soil. Every experiment generates data. Every observation tests implications of natural selection. Emma manages it all. The correspondence alone would overwhelm most people. Darwin sends or receives an average of 5 letters per day for 40 years. That's 70,000 letters. Emma often serves as secretary, writing dictation when his hands shake too severely. She reads incoming letters aloud when his vision swims. She organizes the replies, ensures they reach the post, tracks conversations spanning years. The children become assistants as they age. William and Francis help with experiments. Henrietta edits manuscripts. George, who becomes a mathematician, helps with statistical calculations. The entire household becomes an engine supporting Darwin's work. Everyone has a role in the ecosystem Emma designed, and slowly, steadily, the theory solidifies. 20 years after the Beagle voyage, Darwin has notebooks filled with evidence, thousands of observations, hundreds of experiments, correspondence with experts in every relevant field. The argument is nearly complete. Natural selection explains everything: the diversity of species, the extinction of forms, the distribution of life across continents, the development of complex organs through gradual steps. But he still doesn't publish. The work is too dangerous, the implications too revolutionary. He needs more time, more evidence, more certainty. Downhouse provides the safety to wait. The illness, paradoxically, provides the excuse. He's too sick to engage in controversies, too weak to defend radical ideas, better to work in private until the case is overwhelming. He doesn't know that time is running out. In Malaysia, a younger naturalist named Alfred Russel Wallace is making observations in tropical rainforests, noticing patterns, thinking dangerous thoughts. The same thoughts Darwin has been developing for 2 decades in secret. Natural selection isn't obvious. Darwin worked for years to see it. But once you see it, once you understand the logic, it becomes inescapable. Wallace is about to see it. The house in Kent, with its gardens and walking paths, its routines carefully managed around illness, its study overlooking experiments, this fortress, where pain is being transformed into discovery, is about to face its greatest crisis. The letter that will destroy 20 years of careful preparation is already in the mail. The race between body and deadline is about to begin, and Darwin, vomiting between 7 and 9 every morning, as predictably as clockwork, has no idea what's coming. For 20 years, Darwin keeps a diary of his own disintegration. Not continuously, there are gaps when he's too ill to write, periods when documenting suffering seems pointless. But the pattern emerges clearly enough. A calendar of pain, a ledger of dysfunction. If Darwin approaches barnacles and finches with scientific precision, he applies the same rigor to his own failing body. The result is one of the most detailed medical records of the 19th century, and one of the most baffling. Let's examine what he documents. Start with the vomiting. Darwin records approximately 60 episodes per month during his worst periods. That's 2 per day, every day, for months at a time. But they're not randomly distributed. The morning attacks 7 to 9 o'clock are nearly universal. The afternoon episodes are sporadic, triggered by stress or exertion, or sometimes nothing at all. The violence of these attacks varies. Some mornings bring only nausea and dry heaving. Others involve violent retching that leaves his throat raw and his muscles aching. He tastes blood. He develops hemorrhoids from the strain. He loses weight despite eating when he can because his body expels more than it absorbs. Then there are the other symptoms. His vision, which he describes as swimming or spotting, deteriorates unpredictably. Some days he can read for hours. Other days, letters blur on the page after minutes. He develops elaborate strategies, large print, specific lighting angles, Emma or his children reading aloud when his eyes rebel. His hands shake, not constantly, but in episodes that make writing impossible. He'll be mid-sentence when the tremor strikes, pen skittering across paper, letters transforming into illegible scrawls. He learns to write quickly during good periods, dictate during bad ones, and plan his work around the body's unpredictable cooperation. Rashes erupt across his face and scalp, angry red patches that itch and burn. Victorian medicine treats these with arsenic compounds that probably make everything worse. The rashes come and go without apparent pattern, sometimes lasting days, sometimes vanishing overnight. Boils plague him repeatedly. These are not small inflammations, but large, painful abscesses that make sitting unbearable, sleeping difficult, concentration nearly impossible. In 1863, he develops boils so severe that he cannot work for weeks. The pain consumes everything. All he can do is lie still and wait for them to drain. His heart behaves strangely. Palpitations strike without warning, the heart racing, pounding, skipping beats. Sometimes these episodes last minutes, sometimes hours. He fears he's dying. The fear itself makes the heart race faster, creating a spiral of panic and physical distress. Headaches arrive like thunderstorms, sudden, crushing. They center behind his eyes or wrap around his skull like a tightening band. Light becomes unbearable, sound is agony. He retreats to darkened rooms and waits for the storm to pass. Victorian doctors examine this catalogue of suffering and propose diagnoses with supreme confidence and zero accuracy. One physician declares it's gout, never mind that Darwin shows none of gout's characteristic joint inflammation. Another insists it's a nervous condition brought on by mental strain. The prescription? Rest and relaxation, as if Darwin's meticulous work schedule isn't already dictated by forced rest. A third doctor blames suppressed gout, a conveniently unfalsifiable diagnosis that explains everything while explaining nothing. The treatments these doctors prescribe range from the merely useless to the actively harmful. Mercury compounds toxic heavy metals that poison patients slowly. Bismuth powders somewhat helpful for nausea but no cure. Opium and morphine effective for pain but addictive and consciousness dulling. Darwin takes them all. He's desperate enough to try anything. Then there's the hydropathy regimen we discussed earlier, Dr. Gully's cold water cure. Darwin subjects himself to this torture multiple times across the years, always hoping this time will be different. It never is. The vomiting continues. The collapses persist. But Darwin, trained in scientific method, keeps trying the experiment, adjusting variables, hoping to find the combination that works. He tries dietary modifications, eliminates food systematically, no meat for months, no alcohol ever, no coffee, no tea, simple bland foods eaten at specific times. The symptoms don't improve. He adds foods back. Still no change. Whatever is wrong with him, it's not responding to dietary manipulation. He experiments with exercise regimens, walking prescribed distances at prescribed times. The sandwalk routine becomes medical treatment as much as contemplation space. Some days, movement seems to help. Other days, any exertion triggers collapse. There's no consistent pattern. The body operates by rules Darwin cannot decode. Friends and family offer advice. Try this remedy. See this doctor. Avoid this food. Work less. Work more. Idleness breeds illness. Every Victorian with an opinion about health weighs in. Darwin, polite but increasingly skeptical, thanks them and continues documenting his own experience. Emma keeps parallel records. She tracks every medicine administered, time of day, dosage, observed effects. 20 doses daily become standard. Pills and powders and tinctures. She notes when Charles vomits after taking medicine versus vomiting before. She records good days and bad days, looking for patterns. Between her documentation and Darwin's own, they create a dataset that would impress modern medical researchers. But no pattern emerges. That's the maddening thing. Darwin, who found patterns in barnacle variations and finch beaks, cannot find the pattern in his own illness. Good periods arrive without explanation. Bad periods strike without warning. Treatments that seem to help one month fail the next. The illness operates by its own inscrutable logic. Years pass, decades. Darwin grows accustomed to suffering the way people grow accustomed to weather. It's simply the condition of his existence. He plans his life around it. Important correspondence gets written in morning windows after the vomiting stops. Experiments that require concentration happen on good days. Routine tasks fill bad days. He maximizes the hours his body allows him. The mystery of his illness becomes almost as famous as his theory. Medical journals publish speculation. Doctors write to propose new diagnoses. Some suggest tropical diseases contracted during the Beagle voyage. Malaria, yellow fever, something exotic and previously unknown to European medicine. But the timing doesn't fit. Symptoms appeared gradually, not suddenly upon return. Chagas disease becomes a popular explanation in the 20th century. That Benchuca bug bite in Argentina, the parasite Trypanosoma cruzi, can cause digestive problems, heart issues, chronic fatigue, all symptoms Darwin experienced. It's plausible, compelling, but not definitive. Chagas disease typically causes organ damage visible in autopsy. Darwin's autopsy, conducted after his death in 1882, shows no such damage. Psychosomatic illness, the idea that mental stress manifests as physical symptoms, gains traction among Freudian analysts. Darwin was developing a theory he knew would outrage religious authorities. His wife was devoutly religious. The psychological pressure must have been enormous. Perhaps his body rebelled as a way of avoiding the confrontation his theory would provoke. It's an elegant explanation. It's also probably wrong. The symptoms are too physical, too consistent, too unresponsive to psychological factors. Arsenic poisoning from his own medications becomes another theory. Victorian medicines contained shocking amounts of toxic substances. Darwin took arsenic compounds for years. Could the cure have been worse than the disease? Possibly. But arsenic poisoning has characteristic symptoms: peripheral neuropathy, skin changes that don't quite match Darwin's presentation. For 150 years, the mystery persists. Medical historians write papers. Conferences debate diagnoses. Darwin's illness becomes a cottage industry for medical speculation. Every new understanding of disease prompts someone to re-examine his symptoms through that lens. Each diagnosis seems plausible until you examine it closely. Then the fit isn't quite right. Something doesn't match. The answer, when it finally arrives, comes from a technology Darwin couldn't have imagined. DNA analysis. In the early 21st century, researchers studied Darwin's descendants, his children, grandchildren, great-grandchildren. They're looking for genetic patterns that might explain familial illness. What they find is a mutation in the MTHFR gene. MTHFR stands for methylene tetrahydrofolate reductase, an enzyme that processes folate and B vitamins. When this gene is mutated, the enzyme doesn't work properly. The body cannot efficiently convert folate into forms it can use. The result? A cascade of symptoms: nausea and vomiting, fatigue, headaches, vision problems, neurological symptoms. Everything Darwin experienced. The condition has a name now: cyclic vomiting syndrome. It manifests exactly as Darwin described episodes of violent vomiting separated by periods of relative normalcy. The severity varies. Triggers can include stress, certain foods, exertion, but the fundamental problem is metabolic. The body cannot process certain nutrients correctly, and the resulting biochemical chaos produces the symptom catalogue. Look at how this diagnosis explains Darwin's experience. The morning vomiting cyclic vomiting syndrome often follows circadian rhythms, striking at predictable times. The unpredictability episodes triggered by factors that vary day to day. The lack of organ damage, it's a metabolic disorder, not an infectious disease or poisoning. The failure of Victorian treatments, none of them address the underlying biochemical problem. Modern treatment involves B vitamin supplementation, particularly methylated forms of folate that bypass the defective enzyme. Simple, effective, not available in the 19th century. If Darwin had been born 150 years later, his illness would have been manageable. A daily supplement, dietary modifications. He might have lived a normal life. But he wasn't born 150 years later. He was born in 1809 into a world where genetic medicine didn't exist, where the very concept of DNA lay a century in the future. He suffered for 40 years from a condition that could have been treated with vitamins. The cruelty of this is almost unbearable to contemplate. Yet here's the strange alchemy. Without the illness, would Darwin have developed his theory so thoroughly? The enforced isolation gave him time. The limitations forced efficiency. The daily experience of suffering, of variation in his symptoms, of struggling to maintain productivity, of routines that survived and those that didn't provided, lived metaphors for natural selection. His body, rebelling against him through genetic mischance, became the laboratory where he experienced firsthand the principles he was discovering. Variation, his symptoms varied endlessly. Selection, only certain work routines survived. Adaptation, he learned to function within severe constraints. Survival against odds that would have crushed others, he persisted. The MTHFR mutation that made Darwin's life a daily struggle, also, in ways we can barely articulate, enabled his greatest achievement. Not because suffering ennobles or because pain purifies, but because the specific nature of his limitation created the specific conditions his genius needed. A healthy Darwin might have become a successful professor, publishing solid but conventional work. The invalid Darwin, working in desperate 2-hour windows between collapses, concentrated his brilliance like light through a lens. Modern patients with cyclic vomiting syndrome sometimes discover their diagnosis through Darwin's story. They read about his symptoms, recognize their own experience, pursue testing that confirms the MTHFR mutation. His suffering, meticulously documented, helps people 160 years after his death. The diary of disintegration he kept becomes diagnostic tool for the future. Even in illness, even in failure of his own body, Darwin advances understanding. The body's rebellion that should have destroyed his productivity instead refined it. The genetic error that should have rendered him irrelevant instead made him indispensable. The suffering that lasted 40 years became the crucible where dangerous ideas transformed into comprehensive theory. Medicine's longest mystery, finally solved, reveals not just what afflicted Darwin, but how affliction itself became achievement. There's a paradox at the heart of Darwin's achievement that bears examining. The illness that should have ended his career instead accelerated it. The body that failed him forced him to develop methods that made his insights sharper, his evidence stronger, his arguments more complete than they would have been had he enjoyed robust health. Sometimes limitation doesn't merely test character, it forges entirely new ways of working. Consider what Darwin loses when illness confines him to Down House. He cannot attend scientific society meetings in London, cannot present papers, or engage in the formal debates that establish scientific reputations, cannot visit museums to examine specimens or universities to consult with colleagues. The entire apparatus of Victorian scientific life, the lectures, the demonstrations, the face-to-face collaborations becomes inaccessible. For most scientists of his era, this isolation would mean irrelevance. Darwin invents something different. He builds a distributed research network using the one tool his illness allows: correspondence. Letters become his laboratory. The postal system becomes his research assistant. From his study at Down House, he reaches across continents. The scale of this operation is staggering. 15,000 letters across his lifetime, an average of 5 letters per day for 40 years. But these aren't casual notes. They're carefully crafted research instruments. Darwin asks specific questions, requests particular observations, describes experiments others might conduct. He's orchestrating a global research project while confined to Kent. To pigeon breeders in India, he writes asking about breeding strategies and variation in offspring. To gardeners in Tasmania, he requests information about plant hybridization. To ship captains, he sends queries about animal distribution on remote islands. To naturalists in South America, he poses questions about species variation. Each correspondent becomes an extension of Darwin's senses, observing what he cannot observe, collecting what he cannot collect. The responses arrive in canvas bags delivered by postal coaches. Darwin opens each letter with anticipation. Inside might be descriptions of orchid pollination in Brazil, sketches of pigeon skeletons from Egypt, seeds from Australian plants, pressed flowers from African highlands, data about cattle breeding in Scotland. The world flows to Down House through the mail. This method has unexpected advantages. Darwin can pursue dozens of research questions simultaneously. While waiting for a response from Madagascar about lemurs, he's corresponding about barnacle distribution with a naturalist in Chile, and about earthworm behavior with a gardener in Surrey. His limited work hours don't constrain his research scope. They just mean each investigation proceeds in parallel rather than sequence. More importantly, the correspondence network brings him evidence from environments he could never visit himself. Even if Darwin were healthy, he couldn't sail to every island, climb every mountain, explore every ecosystem relevant to his theory. But through his correspondence, he effectively does. A sick man in Kent gains observational range exceeding the healthiest field naturalist. The illness shapes his working methods in other crucial ways. Those 2-hour windows between morning vomiting and afternoon collapse force brutal efficiency. Darwin cannot afford to waste time, cannot spend hours pursuing tangents or getting lost in interesting but irrelevant details. Every minute of clarity must count. He develops strategies. The most important thinking happens on the sandwalk, where physical movement seems to clarify mental processes. Walking doesn't require the concentration that reading or writing demands. He can walk when his head pounds, when his vision swims, when holding a pen is impossible. And while walking, problems solve themselves. The rhythm of footsteps, the counting of pebbles, the familiar path, these allow his mind to work on problems at angles his conscious attention cannot reach. When he returns from walking with insights crystallized, he writes quickly, racing against the collapse he knows is coming. His handwriting from good periods is neat and controlled. From desperate periods, it deteriorates into scrawls, letters large and shaky, words running together, sentences abandoned mid-thought because exhaustion overtakes him. But he writes, captures the thought before his body shuts down. Emma or his children can decipher the handwriting later. He learns to work in modules, a letter to one correspondent, a paragraph of manuscript, an observation recorded in his notebook, small complete tasks that fit within 20-minute intervals. When collapse comes, he hasn't left work half-finished. Each module stands alone, ready to be assembled later into larger arguments. The enforced rest periods become part of the creative process. Ideas need time to ferment. Connections between observations need time to form. Darwin's illness gives him no choice but to step away from problems regularly. And in stepping away, he often finds solutions. The mind continues working when the body forces rest. He wakes from afternoon naps with insights he didn't have before lying down. This rhythm-intense work, forced rest, contemplation while walking, return to work becomes so ingrained that Darwin cannot imagine working any other way. The illness trains him in a method that maximizes his particular genius. Another scientist might thrive on long, uninterrupted stretches of work. Darwin's mind sharpens through these cycles of focus and release. The symptoms themselves become teachers. Darwin lives daily with variation. His health varies hour to hour, day to day, month to month. He cannot predict whether tomorrow will be productive or lost to vomiting. This unpredictability mirrors what he observes in nature. No two organisms are identical. No environment remains constant. Variation is the fundamental condition of existence. He lives with selection pressure. Only certain work methods survive. Strategies that demand sustained energy fail immediately. Approaches requiring travel are impossible. Techniques needing laboratory facilities are inaccessible. What survives? Methods adapted to his constraints. The correspondence network survives because it works within his limitations. The modular work style survives because it maximizes limited windows. The sandwalk thinking survives because it requires only what his body can give. He lives with adaptation. Every aspect of his routine adapts to the illness. The study positioned to overlook gardens so he can observe experiments from his chair. The high desk for standing when sitting hurts. The armchair for reclining when standing becomes impossible. The signal system with Emma so visitors don't drain his limited energy. Each adaptation increases his functional capacity within severe constraints. The theory of natural selection emerges from this lived experience. Not because Darwin consciously models the theory on his illness, he's too immersed in daily suffering to see that parallel, but because his mind, working within these constraints, naturally thinks in terms of variation, selection, and adaptation. These aren't just abstract principles observed in finches and barnacles. They're the structure of his daily existence. Consider how the illness protects his dangerous idea during its vulnerable development. In London, attending scientific societies, Darwin would have to discuss his work in progress. Colleagues would ask questions, raise objections, push for publication. The social pressure to share incomplete thoughts would be enormous. At Down House, protected by Emma's careful management of visitors, Darwin can develop his theory in private. The illness provides perfect excuse. He's too unwell for extended discussions, too fragile for controversy. The theory gestates in safety. When he begins his 8-year barnacle study in 1846, friends think he's avoiding his revolutionary work. In truth, he's building credibility. But the barnacles teach him more than he expects. He observes variation at microscopic levels, sees how tiny differences accumulate, studies how organisms adapt to extreme environments. Every barnacle specimen adds data supporting natural selection, though he's ostensibly studying taxonomy. The illness forces him to choose quality over quantity. He cannot dash off quick papers on many topics, cannot maintain the publication rate expected of ambitious Victorian scientists. Instead, he pours everything into fewer, more thorough works. When Origin of Species finally publishes, it's overwhelming in its comprehensiveness. Darwin has accumulated evidence from geology, paleontology, embryology, biogeography, animal breeding, plant cultivation, every field that might inform questions about species change. This thorough approach reflects his working constraints. He has 2 hours daily, maybe 3 on good days. Those hours must be maximized. Better to build one unassailable argument than scatter energy across multiple weak ones. The illness forces the choice that makes his work revolutionary rather than merely interesting. His correspondents become more than research assistants. They become the eyes and hands Darwin lacks. When he needs information about expression of emotion in different faith cultures, He writes to missionaries and colonial administrators worldwide. When he's studying orchid pollination, he requests live specimens sent carefully packed. When he's investigating earthworms, he asks gardeners everywhere to examine their soil. His network compensates for his immobility. And because he cannot visit these correspondents personally, he cannot repay their help with social visits or formal acknowledgement. He develops different currencies, detailed responses to their questions, help publishing their own observations, generous citation in his work, recommendation letters for positions. Darwin makes his correspondents feel valued, makes their contributions matter. The network becomes self-sustaining. The contrast with his rival Alfred Russel Wallace is instructive. Wallace is healthy, vigorous, travelling constantly through Malaysia's tropical islands. He collects specimens, makes observations, experiences nature directly. Yet Wallace's insight into natural selection, though brilliant, lacks Darwin's comprehensive evidence. Wallace sees the principle clearly but hasn't spent decades testing it against every possible objection. Darwin, confined to Down House, unable to travel, builds the more complete theory. Why? Because his method correspondence, extensive reading, endless experimentation in his gardens, decades of accumulated observations, generates a depth Wallace's fieldwork cannot match. The illness that seems like disadvantage creates the conditions for thoroughness. There's a lesson here about creativity under constraint. We imagine freedom as prerequisite for genius. Give people unlimited time, unlimited resources, unlimited energy, and watch them flourish. Sometimes this works, but sometimes, often constraint forces innovation that freedom cannot achieve. Darwin's 2-hour work windows force efficiency. His inability to travel forces correspondence networks. His need for manageable tasks forces modular thinking. Each limitation, accommodated, becomes strength. The transformation isn't mystical or inspirational in the usual sense. It's practical. When conventional methods become impossible, you invent unconventional ones. When normal career paths close, you forge new ones. When standard working hours aren't available, you maximize the hours you have. Darwin doesn't transcend his illness through willpower. He works within it through method. By the time he's forced to publish Origin of Species in 1859, Darwin has refined his working methods for 20 years. The illness has taught him everything he needs: how to work in fragments, how to build evidence across correspondence, how to protect vulnerable ideas during development, how to choose thoroughness over speed. The manuscript that emerges contains 20 years of suffering, yes, but also 20 years of method developed specifically for his constrained circumstances. The book succeeds not despite his illness, but partly because of how the illness shaped its creation. The comprehensive evidence reflects decades of work in small increments. The careful argumentation reflects years of private refinement away from immediate criticism. The thoroughness reflects a man who knew he might only get one chance to make his case, who used his limited working hours to build something undeniable. And the method Darwin develops the correspondence network, the modular work style, the balance of intense focus and necessary rest. This method outlives him. Scientists after Darwin adopt similar approaches, not because they're ill, but because they recognize the efficiency. Working in focused intervals, building collaborative networks, choosing depth over breadth. Darwin's constraint-born methods become standard practice. The prison of illness becomes the laboratory of innovation. The body's rebellion forces the mind to develop strategies that prove superior to conventional approaches. What begins as desperate accommodation becomes revolutionary method, and the theory that emerges dangerous, comprehensive, undeniable, bears the marks of how it was made. Forged in 2-hour increments, built through letters crossing oceans, refined through decades of enforced contemplation, natural selection discovered by a man whose own life embodied its principles. The letter arrives on June 18, 1858. Darwin opens it without premonition. It's from Alfred Russel Wallace, a naturalist working in the Malay archipelago whom Darwin has corresponded with occasionally. Wallace is younger, vigorous, travelling through tropical rainforests while Darwin sits confined in Kent. The letter contains an essay Wallace has written. He's asking Darwin to review it, possibly forward it to Charles Lyell for publication consideration. Darwin reads the first page. His hands begin to shake, not from his usual tremor but from shock. Wallace has discovered natural selection, independently, the exact principle Darwin has been developing in secret for 20 years. The essay lays it out clearly. Organisms vary, they struggle for existence, favorable variations survive and propagate. It's all there. The dangerous idea, Darwin thought, was his alone. He writes immediately to Lyell. Your words have come true with a vengeance that I should be forestalled. I never saw a more striking coincidence. If Wallace had my manuscript sketch written out in 1842, he could not have made a better short abstract. Even his terms now stand as heads of my chapters. The devastation is complete. 20 years of work, thousands of observations, 15,000 letters building evidence, all potentially reduced to a footnote. Darwin was working on similar ideas, but Wallace published first. Priority in science means everything. The first to publish gets credit. The second becomes the also-ran, the person who almost made the discovery. But Darwin's body chooses this moment for its cruelest rebellion. His daughter, Henrietta, has been ill with what they think is diphtheria. She's recovering slowly. Then his youngest son, Charles, just 18 months old, develops scarlet fever. The household erupts into medical crisis. Victorian childhood diseases are often fatal. Darwin and Emma watch helplessly as baby Charles's fever climbs. His small body burns. He cannot keep down food or water. On June 28, 1858, baby Charles dies. The same day Darwin is grappling with Wallace's letter. With the threat to 20 years of work, his son dies in his arms. The grief is crushing. Annie's death 7 years earlier broke something in Darwin. This second loss reopens wounds that never fully healed. Darwin's own illness, already severe, becomes catastrophic. The vomiting intensifies. His entire digestive system seems to shut down. He develops boils so painful he cannot sit, cannot work, cannot think clearly through the fog of grief and physical agony. At the moment when he most needs to act, to publish, to establish priority, to defend his claim, his body renders him incapable. Friends intervene. Charles Lyell and Joseph Hooker, both respected scientists who know about Darwin's long-developing theory, arrange a solution. They'll present both Darwin's and Wallace's work jointly to the Linnean Society. Darwin's priority will be established through his earlier manuscript sketch from 1842 and a letter to Asa Gray outlining the theory. Wallace will get credit for independent discovery. It's fair, honourable, and preserves Darwin's claim. The joint presentation happens on July 1st, 1858. Darwin doesn't attend. He's burying his son. The papers are read to a small audience at the Linnean Society. The reception is muted. No one realizes they've just heard the most revolutionary idea in biology. The president of the society will later remark that 1858 produced no remarkable discoveries, but Darwin understands that joint publication isn't enough. Wallace's essay is clear and concise. Darwin's brief extracts hint at a larger theory but don't prove it. If Darwin wants to convince the scientific world, if he wants natural selection to be his legacy, he must write the full book, all the evidence, all the arguments, everything he's been accumulating for 2 decades. And he must do it now, while grief and illness rage through his body. He gives himself 13 months. 13 months to compress 20 years of research into a single comprehensive work. It's an impossible deadline. His health allows perhaps 2 hours of work daily, some days less, some days none. But he has no choice. Wallace is still in Malaysia, still making observations, possibly developing additional insights. Other naturalists, reading the Linnean Society papers, might pursue similar lines of thought. The window for establishing his comprehensive case is narrow and closing. He begins in July 1858. The structure is clear in his mind. He's been planning this book for years, but planning and executing are different things. Each chapter requires marshalling evidence from multiple fields: geology, paleontology, embryology, geographic distribution, domestic breeding, behavior. Each claim must be supported by observations, experiments, correspondence with experts. The writing happens in snatches, morning after the vomiting subsides, if it subsides, afternoons, when exhaustion doesn't overwhelm him completely, evenings, when the pain from boils allows concentration. He writes quickly during good periods, knowing collapse is imminent. His handwriting deteriorates as the months progress, larger, shakier, increasingly desperate. Emma becomes more than wife and nurse. She's his editor, his secretary, his first reader. When his hands shake too violently to write, she takes dictation. When his prose becomes tangled from exhaustion, she suggests clarifications. When his arguments need strengthening, she asks questions that force him to think more clearly. She's enabling work that undermines her faith, helping birth a theory that threatens her worldview, because she loves the man and understands the importance of what he's doing. The children help too. William and George, older now, conduct experiments at Darwin's direction. Henrietta, recovered from her illness, copies manuscript pages in neat handwriting. Francis assists with observations. The entire household becomes focused on getting the book finished. Darwin writes through the autumn of 1858, through winter. Into spring of 1859, the manuscript grows. Chapter follows chapter, the case builds. Evidence from artificial selection, pigeon breeding, cattle domestication, plant cultivation. Evidence from geographic distribution, island species, continental patterns. Evidence from morphology, homologous structures, suggesting common ancestry. Evidence from embryology, similarities in development across species. Evidence from paleontology, the fossil record showing progression over time. Each argument must be airtight. Darwin knows the controversy this book will trigger. Religious authorities will attack it. Conservative scientists will resist. He cannot afford logical gaps or weak evidence. Every claim must be supported multiple ways. Every potential objection must be anticipated and addressed. The working title is An Abstract of an Essay on the Origin of Species and Varieties Through Natural Selection. It's meant to be an abbreviated version of a much longer work Darwin has planned. But as the manuscript grows 100 pages, 200 pages, 300 pages, the abstract becomes a substantial book in itself. By summer of 1859, he's nearing completion. The physical cost is evident. His weight has dropped. The boils come and go with increasing frequency. The vomiting is relentless. He's pushing his body beyond its limits, and his body is fighting back. But the end is visible. A few more chapters, a few more months. He sends completed chapters to friends for review. Thomas Huxley reads them and becomes an instant convert to natural selection. He writes to Darwin offering to defend the theory publicly. Becoming Darwin's bulldog in debates Darwin is too ill to attend. Lyell reads and worries about the theological implications, but admits the evidence is overwhelming. Hooker provides botanical expertise and strengthens the plant-related arguments. In October 1859, Darwin writes the final chapter. His conclusion is careful. almost understated given the revolutionary nature of what came before. He acknowledges that his theory will face opposition. He suggests that younger scientists, unbound by old certainties, will more readily accept it. He ends with one of science's most famous passages, though he doesn't know it will become famous. There is grandeur in this view of life, with its several powers, having been originally breathed into a few forms or into one, and that, whilst this planet has gone cycling on according to the fixed law of gravity, from so simple a beginning, endless forms most beautiful and most wonderful have been and are being evolved. The manuscript goes to the publisher, John Murray, in November. Murray accepts it immediately, recognizing something significant, though perhaps not grasping how significant. The print run is set at 1,250 copies. The publication date, November 24th, 1859. Darwin collapses. The 13 months of desperate work, the grief over his son, the constant illness pushed to its limits, everything catches up. He retreats to his bed. Emma manages the final publication details. The children tiptoe through the house. Darwin lies in darkened rooms, too exhausted even to vomit, waiting for his body to remember how to function. On publication day, he's barely conscious of the event. All 1,250 copies sell immediately. Murray orders a second printing. The reviews begin appearing, some praising, some horrified, all recognizing that something momentous has occurred. But Darwin doesn't read them, cannot read them. His eyes won't focus, his head pounds. He's used up every reserve. The battle he cannot fight personally begins without him. Huxley steps forward as chief defender. In June 1860, Bishop Samuel Wilberforce attacks the theory at Oxford, confident he can demolish it with rhetoric and religious authority. Huxley responds with scientific evidence and logical argument. The exchange becomes legendary. Wilberforce sarcastically asks whether Huxley claims descent from apes through his grandfather or grandmother. Huxley replies that he'd rather be descended from an ape than from a man who uses eloquence to obscure truth. Darwin hears about these confrontations through letters. Huxley reports the debates. Hooker describes the growing acceptance among younger naturalists. Lyell admits his own conversion to evolution, though he struggles with applying it to humans. The theory spreads through the scientific community, while its author remains confined to Down House. The book that emerged from 13 months of desperate work transforms biology. Within a decade, most naturalists accept evolution as fact, though debates about mechanisms continue. Darwin's comprehensive evidence makes denial difficult. The agricultural breeding examples are undeniable. The geographic distribution patterns are clear. The fossil record, though incomplete, shows progression. The morphological similarities suggest common ancestry. The cumulative case is overwhelming. But the cost to Darwin is devastating. He never fully recovers from the race against Wallace and time. The 13 months of intense work followed by complete collapse establish a pattern that will continue. Periods of focused effort, alternating with periods of total incapacity. His body will not forgive being pushed so far beyond its limits. In some sense, Wallace's letter saved Darwin from himself. Without the deadline it imposed, Darwin might have continued refining his theory for another decade, adding more evidence, anticipating more objections, never feeling quite ready to publish. The crisis forced completion. The body's rebellion during that completion almost prevented it, but somehow, through 13 months of vomiting and grief and physical agony, the work got done. The race against body and time ended with Darwin victorious but broken. The theory was published. His priority was established. Natural selection entered the world. And Darwin, having given everything his failing body could give, retreated into the illness that would define his remaining years. The dangerous idea was out. Now others could fight for it. He had done what he needed to do, paid the price his body demanded, and transformed human understanding of life on Earth. The prison of illness had accomplished something remarkable. It had both nearly prevented and ultimately enabled the revolution. Darwin dies on April 19th, 1882. He's 73 years old. The final years have been gentler than the middle decades. His body, having tortured him for 40 years, seems to ease its grip slightly. The vomiting continues but less frequently. The collapses still come, but allow longer windows between them. He works until nearly the end, publishing books on earthworms and plant movement, orchid fertilization, and human emotion. His mind remains sharp, even as his body finally, slowly, fails completely. They bury him in Westminster Abbey, near Isaac Newton. The irony would amuse him if he could appreciate it. The invalid who couldn't attend scientific meetings, who missed his own father's funeral, who spent 4 decades confined to a country house he's honoured with burial among England's greatest heroes. The man whose theory threatened Victorian religious certainty is laid to rest in the nation's most important church. The dangerous idea has won, but Darwin's real legacy isn't his burial location or the honours accumulated. It's something stranger and more profound. He created a template for transforming limitation into achievement. The prison of chronic illness that should have destroyed his productivity became instead the laboratory where genius concentrated itself. And this template propagates forward through time, appearing in unexpected places, proving that Darwin discovered something about human potential as well as biological evolution. Consider Temple Grandin. Born in 1947 with autism in an era when autism meant institutionalization, when doctors told her mother she'd never speak or function independently. The condition that should have limited her instead gave her unique insights. Her visual thinking, the way her mind processes information in pictures rather than words, allowed her to understand how animals perceive their environment. She revolutionized livestock handling by seeing slaughterhouses through cattle eyes, designing facilities that reduce animal stress. The difference that should have disabled her became her greatest strength. She explicitly cites Darwin's example, the invalid who changed biology from his sick room, or Stephen Hawking. In 1963, diagnosed with motor neuron disease, given 2 years to live. The disease that should have ended his career forced him to work entirely in his mind. Unable to write equations on paper, he developed the ability to rotate complex mathematical structures mentally, to see solutions that others reached through pages of calculations. Confined to a wheelchair, unable to speak except through a computer, he unlocked secrets of black holes and the universe's origin. The limitation forged the method that produced the insights. These aren't inspirational platitudes about overcoming adversity. They're specific examples of how constraint creates innovation. Darwin showed that when conventional approaches become impossible, unconventional approaches emerge. When normal working hours aren't available, you maximize the hours you have. When standard career paths close, you invent new ones. The pattern repeats across generations because the pattern works. Darwin's medical records, once merely the documentation of personal suffering, become diagnostic tools. In 2015, a woman in California reads about Darwin's cyclic vomiting syndrome. She's suffered similar symptoms for years: violent morning nausea, unpredictable episodes, exhaustion that confines her to limited work hours. Multiple doctors have found nothing wrong. But reading Darwin's meticulous symptom diary, she recognizes her own experience. She requests genetic testing. The MTHFR mutation appears in her results. Treatment begins: B vitamin supplements, dietary modifications. Her symptoms become manageable. Darwin's suffering, recorded with scientific precision 160 years earlier, helps a stranger find diagnosis and relief. This happens repeatedly. Darwin's case becomes a teaching tool in medical schools. Students learn to recognize cyclic vomiting syndrome by studying his letters. Patients discover their condition by reading about his life. The diary of disintegration becomes medical literature. Even in illness, even in failure of his own body, Darwin advances understanding. But the deeper legacy is methodological. Darwin demonstrated that productivity isn't about hours worked or energy available. It's about method matched to constraint. His correspondence network, his modular work style, his balance of intense focus and necessary rest, these approaches work whether you're chronically ill or not. Modern science adopts them not because scientists are sick, but because the methods are efficient. Collaboration through correspondence becomes standard. Scientists across continents work together without meeting. Email replaces Darwin's letters but serves the same function, extending reach beyond physical presence. The global research network he invented becomes how all science operates. Working in focused intervals becomes recognized wisdom. The Pomodoro technique, invented in the 1980s, 25 minutes of concentration, followed by rest mirrors, Darwin's enforced method. Productivity experts discover that humans work better in cycles of effort and recovery. Darwin knew this because his body gave him no choice. Choosing depth over breadth becomes career strategy. Better to build one comprehensive case than scatter energy across multiple weak ones. Darwin's example shows the power of thoroughness. Origin of Species succeeds because it's overwhelming in its evidence. 20 years of accumulated observations, compressed into 13 desperate months, create an argument that cannot be dismissed. The physical place where this happened, Down House, still stands. Visitors walk through rooms that feel haunted by absence. The study where Darwin wrote between bouts of vomiting. The bedroom where Emma administered 20 doses of medicine daily. The gardens where experiments tested ideas about plant fertilization and earthworm behavior. And the sandwalk, the thinking path, still there after 160 years. People walk the sandwalk now. They place flint pebbles at the start, kick them aside with each lap, just as Darwin did. They're not recreating his method out of nostalgia. They're discovering that it works. The rhythm of walking, the mechanical counting, the familiar path, these free the mind for contemplation. What Darwin developed from necessity becomes adopted by choice. The irony is inescapable. The house bought as refuge from illness becomes pilgrimage site. The gardens planted for private experiments become public testament. The walking path worn by 10,000 circuits of desperate thinking becomes place where others seek inspiration. The prison transforms into shrine. But perhaps that misses the point. Down House wasn't just prison. It was laboratory, library, experimental station, correspondence hub, and thinking space. The illness confined Darwin physically, but forced him to expand methodologically. The walls that closed in around him became launching point for ideas that conquered the world. Consider the final accounting: 40 years of suffering, 14,600 days of managing symptoms, 12,000 episodes of vomiting, countless hours of headaches, tremors, vision problems, boils, exhaustion. Against this, weigh the achievement. Natural selection discovered, documented, proven. Evolution established as biological fact. Human understanding of our place in nature fundamentally transformed. Every biological discovery since 1859 branches from Darwin's central insight: was the suffering worth it? The question seems almost obscene. Suffering isn't something we trade for achievement. Darwin didn't choose illness in exchange for insight. The MTHFR mutation that caused his cyclic vomiting syndrome was genetic accident, meaningless biochemistry. But given that the suffering happened anyway, given that Darwin had to live those 40 years regardless what he made from them is extraordinary. He could have surrendered to invalidism. Many Victorian invalids did, spending decades in darkened rooms accepting their fate. Darwin chose differently. Not heroically, not through willpower or inspiration, but through method. He engineered an environment where limited capacity could produce unlimited insight. He developed working approaches matched to his constraints. He turned 2-hour daily windows into sufficient time for revolution. The lesson propagates forward. Not everyone can be Darwin. Not every constraint produces genius. But the template exists now, the demonstration that limitation can be accommodated, that severe constraint doesn't mean surrender, that productivity is about method more than capacity. Every person working within difficult circumstances has Darwin's example. The invalid who rewrote life's story from his sick room. His theory itself explains why this matters. Natural selection operates through variation and constraint. Organisms vary in their traits. Environments constrain which traits survive. The constraint isn't obstacle to evolution, it's the mechanism. Without selection pressure, without limitation, there's no evolution. Constraint creates the conditions for adaptation. Darwin lived this principle. His constraint chronic illness created selection pressure on his working methods. Only approaches suited to his limitations survived. The correspondence network survived because it worked within his constraints. The modular work style survived because it maximized limited windows. The thorough evidence building survived because rushed work was impossible. Constraint selected for methods that proved superior, even without constraint. We stand now, 165 years after Origin's publication, living inside implications Darwin could barely imagine. Genetics, the molecular mechanism of inheritance he never knew, proves his theory at the deepest level. DNA shows the common ancestry he proposed. Evolution explains antibiotic resistance, cancer development, ecosystem dynamics, human psychology. The dangerous idea has become foundational truth, and the medical mystery that plagued Darwin's life is solved. The MTHFR mutation identified. Cyclic vomiting syndrome understood. Modern patients with his condition take B vitamins and manage their symptoms. Simple, available, too late for Darwin by more than a century, but perhaps it had to be too late. Perhaps Darwin needed exactly his circumstances, the suffering, the limitation, the constraint, to develop the methods that produced his insights. A healthy Darwin might have become a successful professor, publishing solid, conventional work, never quite seeing the dangerous idea clearly enough to pursue it. The invalid Darwin, working in desperate 2-hour increments between collapses, concentrated his brilliance like light through a lens. There's no justice in this. No cosmic fairness balancing suffering with achievement. Just the historical fact that this person, with these limitations, in these circumstances, discovered what no one else had seen. And in discovering it, he showed something about how limitation and achievement can combine. Walk the sandwalk at Down House on a quiet afternoon. The path is still there, worn by countless feet following Darwin's circuits. The woods have grown and been managed and grown again. The flint pebbles people place are different stones than Darwin kicked aside. But the rhythm remains, the walk, the count, the thinking that happens when body moves and mind is freed to wander. Somewhere in those circuits, between the counting and the walking, Darwin solved the mystery of life's diversity, not through superhuman effort, not through transcending his illness, but through working within it, through method matched to constraint, through 40 years of refusing to surrender despite every reason to surrender. The invalid who rewrote life's story did more than discover evolution. He demonstrated that suffering doesn't have to mean silence, that limitation doesn't require surrender, that the prison of chronic illness can become the laboratory of transformation. The echo of that demonstration carries forward through time, inspiring not through sentiment but through example. Darwin showed it could be done. That's the eternal echo, not the suffering transformed, but the transformation that suffering made possible. And in a small house in Kent, in gardens now preserved, On a walking path worn smooth by contemplation, the space where it happened remains. A monument not to triumph over adversity, but to something more complex and real, the accommodation of limitation, the engineering of method, the patient building of comprehensive truth in narrow windows snatched between the body's rebellions. The dangerous idea was born here, in these constraints, through these methods, despite this suffering. Because of it? Perhaps. The prison and the laboratory, inseparable, remain.